Now we are going to solve our first system of differential equations. It'll be a quite simple example, but we're going to go through all of the steps. This, in fact, is going to be two first-order linear ODEs. Here's the problem. So here's what we're given. dx dt is equal to 3y. dy dt is equal to 2x. So we're going to do a little simplifying, and we're going to bring the differential operator into this. dx dt is just capital Dx. dy dt is capital dy. And now let's write it the way we normally write it. On the left-hand side, we have all the functions of x and y and their derivatives. And on the right, we have the function of t, which for us is just going to be 0. So we have two homogeneous first-order linear differential equations. First thing we're going to do, and this was arbitrary, we're going to solve for x by eliminating y. Okay, we could have started the other way. Then you'll see what we're doing after that. We're going to solve for y. And to do that, we'll eliminate x using these two equations, 1 and 2. So let's see what we have to do. If I want to eliminate x, remember what you're doing? Remember linear algebra, or even pre-calculus maybe, working with matrices? I need to multiply, or in this case, multiply by a number or apply a differential operator to make essentially the coefficients of the y be identical in the two equations. And by identical, I mean opposite of each other. One will be positive, one will be negative. And then when I add the two equations, they'll disappear. So I have a negative 3y here, and I have capital D applied to y there. So I'm going to need a capital D up here, which means I will apply D to 1. I think that's all I need to do for that. That would give me a negative 3 dy. And then I have a dy here, so I need to multiply by 3, equation number 2. That might look kind of funny. Apply d to equation 1, multiply by 3, equation number 2. So if we apply d to this whole equation, I'm going to get d squared, right? D times d is d squared, x minus 3 dy equals 0. The second equation, multiply by 3, negative 6x minus, by 3, so it's going to be a plus 3 dy equals 0. So what do we get when we add those two equations together? When we add them, this drops out. And I get d squared x minus 6x equals 0. So this, we know how to solve. This is what? X double prime, minus 6 equals 0. This is a second order linear ordinary differential equation with constant coefficients, and it's homogeneous. It's simple to solve. We'll use the characteristic equation. Sorry, I'm having to write really small here. The characteristic equation would be m squared minus 6 equals 0. So from there, I get m equals, well, if you treat it like the difference of two perfect squares, it would be m plus radical 6, m minus radical 6. So it's going to be plus or minus radical 6. We got two distinct roots. So that means we know the solution. X of t is equal to, hopefully you have this memorized, two distinct solutions to the characteristic equation means C1 e to the radical 6t plus C2 e to the negative radical 6t. So you might think we're halfway done. We're not quite. We did solve for x. Let's see. I'm going to have to squeeze it in down here. We're going to do a similar thing. We're going to go back up to here, back up to this equations 1 and 2. This time solve for y. And then we'll eliminate x. By eliminating x, we will solve for y. So how do I eliminate x? I need them both to be, let's see, if this one were 2dx and this were minus 2dx, they would cancel each out when I add them. So I'm going to multiply by 2 equation 1. And then I'm going to apply d to equation number 2. That'll eliminate the x's. So multiplying by 2 upstairs on this one, I get 2dx. I get 2dx minus 6y equals 0. And then the second equation, I'm applying d to it. So I get negative 2dx plus d squared y equals 0. All right, so when I add those two equations together, these drop out, the 2dx and the negative 2dx. So I'm going to get d squared y minus 6y equals 0. And then I'm going to get, let's see, the characteristic equation. This would be y double prime minus 6 equals 0. Wow, it's the same as last time. Y double prime minus 6. I thought they came out slightly different. Y double prime and x double prime minus 6. Yeah, okay, so they come out exactly the same. So we get m squared minus 6 equals 0. So we're going to get the same thing. We are going to get y of t equals, let me write it down here so I can write it a little bit bigger, c1 e to the radical 6t plus c2 e to the negative radical 6t. Oops. Big mistake here. The constants here are c1 and c2. I can't reuse them. They're not the same. This will be c3, and this will be c4. Okay. Now, we have, looks like we've finished this, but we haven't. I may have mentioned this a little bit earlier. This system of two equations, they're both first order differential equations. That means we can only have one constant for each. So I'm only allowed to have two constants here. So we're almost done, but I can't have C1, C2, C3, and C4. This is not the solution for all values of C1, C2, C3, and C4. That's just too many constants for this problem. So we'll take care of that right now. Okay, I put a note up here. Solution to a system of two first-order ODEs can only have two parameters. Basically, the number of parameters is the order of the differential equation. You have two of them, so you'll add them together. For example, if you have a third order in x and a fourth order in y, then you can have 7 constants, 7 parameters. C1 through C7 are parameters. Okay, so we are going to use substitution to eliminate C3 and C4. Or I could have said to figure out exactly what C3 and C4 are. So recall that this was our original equation number 1 and equation number 2 before I applied the differential operators and all of that. So this is what we started with. X, we just solved for it. We know that. But notice that we've got a relationship here between dx dt and y. dx dt, we can now say, is the derivative with respect to t of x, which is this. So dx dt is, let's see what this would be. Let's work this out. dx dt equals c1 radical 6 e to the radical 6t. I think I did that right. If you differentiate this, you have to multiply by radical 6 plus, actually it would be a minus, wouldn't it? Because if you take the derivative of this, you have to multiply by a negative radical 6 e to the negative radical 6t. But what do we know? We know dx dt is equal to this, but dx dt is also equal to 3y. I'll say, but equation 1 implies dx dt is equal to 3 times y. What was y? Y was the same thing, right? I mean, really, it was the same thing as x. So it was c1, sorry, equation 1 says dx dt is 3 times y. So I have to make it 3 c1 e to the radical 6t minus 3 c2 radical 6 e to the negative radical 6t. We know y from the previous board. Remember, it looked just like x, only we had I made the same mistake. That's c3 and that's c4. Now we can figure out what c3 and c4 are. Notice these equations. This is equal to this. Well, these coefficients are the same, so these two things are equal. And these two things are equal. So what does that mean? It means that implies c1 radical 6 is equal to 3 c3. All right, and the other one says that negative c2 is equal to negative 3 c4. So all we need to do with this, we can't solve for c1, c2, c3, and c4. All we want to do is find a representation for 3c3 that involves c1. So, how do I write c3? Yeah, I just need to solve it for c3. And then c4. c3 is equal to c1, I'll put radical 6 over 3 c1. And that's perfectly fine for c3. We got rid of it because it's now going to be radical 6 over 3 c1. And this is going to be c4 equal, divide by negative 3, it's going to be a positive it's going to be a positive 1/3 c2. Let me make sure that's what I got here. C3 is that. C4 is, oh, I missed a radical 6. Yep. Sure you caught that already. I circled this incorrectly. This is negative C2, radical 6. So C4 is radical 6, negative radical 6. And why is it negative? 3C4. Let's see. Should that be negative? Y and X. I think they're the same sign, so I think that's positive. You may want to double check and see if I missed a sign somewhere. But that gives us values for C3 and C4. So this is our value for X. And unfortunately, I kind of ran out of room. So Y is equal to, C3 is radical 6 over 3 C1 e to the radical 6t plus C4 is radical 6 over 3 C2 e to the negative radical 6t. Oops, let me circle it in the same color I did. And I'm using a different color blue, but so this is the solution. I don't have room to write them one on top of the other, but these two equations. Now, I do allow the possibility that I messed up on a sign. I don't think I did, but it's possible that this is actually a negative sign. I don't think I messed up on the sign, but I will allow that possibility that this is actually a minus sign. Hopefully, if I did make a mistake, you're able to figure it out as you're writing this out. So that's our first example.